Hey everyone, welcome to this demo on getting started with Docker. Today, I'll show you how to containerize a simple Node.js project. We'll cover everything from creating a Docker file, building an image, running a container, and more. Docker is great for isolating your app and ensuring it runs the same way no matter the environment. Here's the Node.js project we will be working with. Just a disclaimer, you do not need to know Node.js or have any of the Node.js runtime installed. I'm simply running and installing the dependencies locally to demonstrate this app. So just to summarize, as I mentioned, you don't need to know Node.js, but just to summarize this code, when we get a GET request to the root URL, we send this HTML, which lists out all our tasks stored in this array. When we get a post request to the add task resource, we add the task to the array and redirect the user back to the root URL. And when we get a post request to the remove task resource, we remove a task from our array and go back to the root URL. So let's run this project. First, I will show you the version of Node I am using. So this will be important later, but just to keep track, it's version 20. Next, I will run npm init to initialize my npm project. Next, I will run npm install to install all the dependencies specified in the package.json, so express and body parser. Finally, I will run my app and show it to you. Our app is running on port 3000. Okay, just quickly, I forgot to add the style, so I just quickly copy pasted that. Now we will see the app. Before it didn't have styles, but if we refresh, okay, there's our task manager app, and it's pretty simple. We just add tasks and it gets added to an array when we click this button, and here we display everything in the array, and when we click remove, it removes that task from the array. So it's pretty straightforward. Now we will Dockerize this Node.js project as well as explore other commands for this project. As I mentioned, you only need Docker installed to run this app and nothing else. So first we will open a new window in Visual Studio Code, and I will drag this here. So the thing to note is we just added this styles.css. So check my last tutorial out where I show you how to install Docker if you don't have that installed. It's pretty simple. All you need to do is enable WSL2 on your device by going to turn Windows features on or off, and just go to WSL2 and just install Docker Desktop for Windows. So first, let's run a couple of commands to just explore the Docker environment a little more. First, we will run this docker run node command. The docker run command is used to create and start a container from an image. In this case, the image is Node. The Node part refers to the official Node.js image available on Docker Hub. This image contains everything you need to run a Node.js application, including Node.js itself and its dependencies. When you run this code, Docker will look for the Node image on your local machine. If it is not there, Docker will automatically download it from Docker Hub. Now that we've run docker run node, you might have noticed that it executed without showing much on the screen. Currently, I have this image installed. That's why you didn't even see anything download if you use the docker images command. I had Node from 8 days ago. But let's actually see something. So that's because the reason why we saw nothing is because running a container, it was running a container in the background, but it doesn't keep the terminal open for interaction. To see more and interact with Node.js, we can use the command docker run -it node. The IT flag stands for interactive mode. There's the -i. This flag keeps the standard input open, allowing you to send commands to the container. The -t flag gives you a terminal interface. So when you run docker run -it node, you'll be taken to an interactive Node.js environment where you can type JavaScript code and see the results immediately. So we can type 1 + 1. We can type 33 times 77. We can type console.log hello. One thing to note here is we are using Node.js version 22.9. If you recall earlier, I was on my local machine, I was using Node.js. This is on my local machine. If you do node-v, I'm using version 20. So again, to emphasize that this node environment is running within a container, which is a completely different, separate, isolated, and different version of Node. Now that we've run our Node.js container interactively, let's check our containers and see what's happening in our Docker environment. So we can run the docker ps-a command. The docker ps command lists all the containers on your system. By default, it will show only the running container. So I stop my container so you see nothing here when I run this. The docker ps-a, you'll see a list of containers with several columns of information. So we can use the docker ps-a command to keep track of our containers and their states. Now that we've run some Docker commands and interacted with containers, let's dive into Dockerizing our Node.js application. This means we'll create a Dockerfile, which is a blueprint for building a Docker image of our app. So what is a Dockerfile? A Dockerfile is simply a text file that contains instructions on how to build a Docker image. This image will include your Node.js application, its dependencies, and the environment it needs to run. In the root of the Node.js project directory, let's create a file called Dockerfile without any extension. Next, I added these commands, and let's go over them one by one, explaining what they do. From Node, this line specifies the base image for our container. Here we are using the official Node.js image. This image includes everything needed to run Node.js applications, which means we don't have to install Node.js manually. Working directory /app. So this sets the working directory inside the container to /app. Any subsequent commands we run in the Dockerfile will be executed in this directory. This helps keep our project organized. This copy dot and then /app. So what this does is this command copies all the files from our local project directory. So all of these files that are in the same directory as this Docker file, so server.js and folder, so server.js, package.json, and this public folder will be copied into our container. And specifically, our container is like a mini VM, so it also has a file structure. And we specified in this working directory command that we want to use the moving forward, we are working in the /app folder of our container. So we copied everything from our local machine into the /app folder of our container, which you can kind of think of as a mini lightweight VM. So this includes our application code and any configuration files. Next, we run npm install. So what this does is this line runs npm install inside the container, which will install all the dependencies listed in the package.json file, making sure our application has everything it needs to run. Next, expose 3000. This informs Docker that the application inside the container will listen on port 3000. It's a way to document which port the application uses, making it easier to configure networking later on. Finally, the cmd node server.js. So this command tells Docker how to run your application. When the container starts, it will execute node server.js, making sure server.js is the entry point of your application. So this Dockerfile sets up a complete environment for your Node.js app. It starts with a Node.js image, creates a working directory, copies your code into the directory, installs the dependencies, exposes the necessary port, and finally specifies how to run the app. So with this Dockerfile, we can build our image and run our Node.js app in a container, ensuring that it runs the same way in any environment. Next, we will run this command, docker build -t my node app. So what does this do? This command tells Docker to build a new image based on the instructions in our Dockerfile. The docker build part of the command tells Docker that we want to create a new image. The -t flag stands for tag. This is how we name our image. Here we are naming our image in my node app. This makes it easier to identify and run our image later. The dot at the end of the command, which is important, not an accident. The dot at the end specifies the build context. So in this case, it is the current directory. So Docker will look in this directory, this folder that I'm currently in, using Docker folder. It'll look for the Docker file, and based off that Docker file, it'll build our image. So let's run this. So what just happened? It pulled the Node.js base image. If it's not already on your machine, it sets the working directory, copies your project files, installs dependencies, and sets up the necessary commands. Once the build is complete, you'll have the image named my node app that you can run your Node.js applications in a container. So this command is how we create a Docker image of our Node.js app using our Dockerfile. Once it's built, we'll be able to run our app in a Docker container easily. Before we run our container, let's check out the images we have available on our system. We can do this with the Docker images command. So this shows all of our images on our system. This shows the my node app that we created. Running the command allows to confirm the image was built successfully, and we see my node app in the output. So now we are ready to run our application. We can do this using the following command. So what does this do? This command starts a new container from the my node app image we just created. Docker run. The Docker run part of the command tells Docker that we want to create and start a new container. The -p3000 :3000 flag maps a port from your host machine to a port on the container. The first 3000 is the local machine that we'll use to access your application. And when we open the browser, we go to localhost 3000. And then the second port is your application listening inside the container. In our Dockerfile, we set expose 3000, meaning the application runs on port 3000 in the container. So we'll run this command, And when we run it, Docker will create a container from the mynode app image. Thanks to port mapping, any traffic directed to localhost 3000 will be forwarded to port 3000 on the container where the Node.js app is running. So now we can close this, and we can type localhost 3000 and our app still works. Isn't that great? We can add our tasks, and there it is. So this command allowed us to run a Dockerized Node.js app and make it accessible via the browser. By mapping the container's port to the local machine's port, we can easily interact with the app. And here you can even see in the code we log any of the tasks that the user adds, and they get logged here because it's in an interactive mode in an attached state. So we're seeing everything in this terminal live. If we use the Docker ps command, we can see the container running. The container's name is Sleepy Pain, but this name is assigned by the Docker application randomly. But we can also create a container and assign it our own desired name for easier management. So first I'll show you the Docker stop command. This will stop our Sleepy Pain container. This will take a moment and then it'll stop, so that I can show you how to make a container where we name the container ourselves for easier management. Here our new container, we're running the exact same docker run command, but our container will have the name mynode container. So now it's stopped, so you'll see if we reload this, we'll get an error. It's loading and it is no longer working. And if we run this again, it is listening on port 3000. Here we can now use this terminal. It exited out of the logging state because that container ended. And if we run docker ps, we have now named this new container mynode container, which is great for management. Now, right now this is in an attached mode, so we're able to see everything that's being logged right here, like 1 and 2, and that's being logged here. But another way we can see, let's see if we want to see the logs from this terminal, we can use the docker logs command. So we just write docker logs and then the name of the container. So in this case it's mynode container, and there it shows us all the logs. And if we want to have real-time log viewing, we can use docker logs with the -f flag, which is the follow flag, and then the name of our container. Now we'll get the real-time logs similar to how we're getting them here. And we can add some more tasks. And we're getting those logged to both terminals here and here. So this docker logs command allows us to access and monitor the output from containerized apps easily, whether you want to check the logs at a specific moment or follow them real time. Docker provides the tools for effective logging. Now, one final concept I want to cover is that images are immutable, and I want to explain about rebuilding images. So let's say if I don't want these exclamations here, I just want a smile on the title on my h1 tag of my page. So see, there's 3 exclamations and I want to get rid of these. But if I get rid of them right here and I save my page, nothing changes. And this brings us to an important concept of the immutability of images. Once an image is built, it's considered a finished product. This means that it doesn't change or automatically reflect updates of the code. If you make any changes to your app, you need to rebuild the images for those changes to take effect. So images are like closed templates. They contain everything needed to run your application at the time they were built. Think of them as snapshots of your app. Any modifications you make to your code won't be seen in the image until you rebuild it. So let's go ahead and rebuild it to demonstrate with practical example what I mean. So instead of calling this task manager app, I changed the title, not the thing, but whatever. I'll just call this whatever, app, Docker demo app is what I will give this so that you can see the changes. So now we made this change, we need to rebuild the app. So let's go ahead and Docker build our app. Oh, I'm in the wrong terminal. I'm in the wrong, I've been in the wrong, I've been in the wrong window of my Visual Studio. Okay, yeah, but what I said still applies. Let's just end these containers. Let's just stop this. Docker stop my node container. And again, demonstrate how we need to rebuild the image in order for it to reflect the changes in our app. So Docker demo changes, whatever. So let's now rebuild this with Docker build. And it's rebuilding. It'll get the changes and we'll see those changes. I stopped the container so this thing won't run anymore. We'll now run Docker run. We can see our images. Still got the same. And we'll now do Docker run my node app. So the whole point of showing this is explaining how images are immutable. Images are like closed templates. They contain everything needed to run the application at the time they were built, and they're kind of like snapshots of the application. They do not change or reflect they do not change or update or reflect anything that we modify in the code. We have to rebuild the image and run a new container in order to demonstrate this. I mean, this isn't the only way to do it, but for now it's a beginner tutorial, so that's what I'll show you. That we could see other ways on how to do it, like using volumes and bind mounts for development purposes, but in production typically these Docker files will just be snapshot images of production code. So hopefully you guys have now been able to see the difference between using Docker to Dockerize and run our Node.js app and running it locally on our machine. Docker provides a great way to run applications consistently across environments. And because images are immutable, we need to rebuild them to reflect any changes made to the code. Today we explored the fundamentals of Docker and learned how to Dockerize a Node.js app. We started with the essential commands like Docker run, Docker ps, and Docker images, giving a solid foundation for working with Docker containers. We created a Dockerfile to define the environment for the Node.js app, including how to copy files, install dependencies, and specify how to run the app. We walked through the process of building the image with the Docker build command and running it in a container, along with the importance of port mapping. We discussed how to stop containers, name them for easier management, and view logs to monitor our app. And finally, we looked at how to remove Docker images and containers, emphasizing the need to manage our Docker environment effectively. By understanding these concepts, we can now develop, test, and deploy the Node.js app using Docker. Thank you for watching. Have a nice day, and please subscribe.